The function stack helps us to abbreviate a function like this one, f of 2 plus 3. That means we solve the function. And this is not a problem for us, especially if we know the function f, which gets a figure as an input, then outputs another figure as a solution, and finally adds 5. Now we will try to use the function stack to solve this function automatically with a deterministic method. This works like this. We write down the single characters of the function beginning from the left. I will write them down one underneath the other. We begin with f, open bracket, another f, open bracket, 2, close bracket. And now we have reached this 2, and we have also reached the close bracket of this 2. And every time a bracket closes, this means that something can be abbreviated, something can be calculated. It means something is complete and can be replaced with a shorter term. And this is what we will do. We have found the closing bracket, which is this one. This one is the corresponding open bracket. This is the function, and this is the function value. This means we can replace the complete function. And now, if we look at the function f of 2, we see that the figure of z has the value of 2. And since the function returns z plus 5, we get the value 7. I'll write down the replacement, which is 7. And in our function stack, we still have f, open bracket, but now there is a 7 in there. So after this step is finished, we will proceed. Now there is a plus, and the 3 follows. And finally, the closing bracket. I will have to write it down a little bit higher. And now we have reached a closing bracket again. And this means we have to look for the closing bracket and find the corresponding open brackets, and if we can solve or abbreviate a term between the two brackets by using mathematical operators. And in this case we can do that. 7 plus 3 equals 10. So the 10 replaces the term 7 plus 3. And now we have the value 10 as an input for the complete function, which begins up here and can replace the complete function. The function f gets a value of 10 as an input. This value is saved for the variable z. 10 plus 5 equals 15. And the value 15 can't be abbreviated any further. And that is why the complete function returns the value of 15.